Hello friends. Welcome to Gyan Guru official channel. In this video we will learn about the indoor lighting design and significance of good lighting. Hope you have watched the part 1 in which all necessary terminologies have explained. If you haven't watched yet, then please do watch by clicking the link given in the description of this video before you switch on to part 2 of lighting design. To completely understand the lighting design for indoor and outdoor area, you need to explore the other parts of the video. In this video, we will cover the indoor lighting design calculation and what all factors required to be taken care while designing, such as selection of lighting fixture, uniformity factor, maintenance factor, lux level requirement as per Indian and international standards, etc. Part 3 of the video will cover the exterior lighting terminologies and designing and the factor to be considered while designing road lights, compound lighting, etc. All three parts of the video is based on the Indian standard and international standards which we used while designing. Before starting, don't forget to subscribe our channel and press the bell icon to get the automatic updates whenever we upload the videos. Videos are made with the aftermath of detailed research so that we can provide you the legitimated information based on certain references. At the end of the video, we would be happy if you provide the genuine feedback. Numerous questions are roaming around your mind. Like, what are the acceptable lux levels as per Indian standard or international standard? How many fixtures will come in a particular area? From where I get lux level? As a designer, what all necessary things need to be considered? Answer to each question resides in this video. Let's begin the learning. First question strikes in everyone's mind is how to determine numbers of luminaries in a room. Here is the simple formula to this question. To determine numbers of light fixtures of a room, we need to multiply the area of room with the average lux required in room. And then outcome of multiplication has to be divided by the lumen output of each lamp along with the coefficient of utilization and maintenance factors. To understand the formula completely, we will understand the each terms highlighted here separately. For the recommended value of average lux level or illuminance, one can refer the National Building Code 2016, Part 8 Building Services, Section 1 Lighting and Natural Ventilation. There is a table 4, named as Recommended Value of Illuminance. In that table, you will find the recommended value of illuminance for various applications. Similarly, in IS 3646, one can refer the Table 1 of Part 1. And for more information on recommended value of lux level, you may refer the Table 2 of National Lighting Code SP 72. These standards are free to access. You can download at free of cost. In this video description, you can find the links for downloading these standards. Recommended value of average lux level or illuminance shown here is taken from the Indian Standard 3646. Table shown here is for building services. In any kind of building, we have entrance halls, circulation areas, medical room and staff room. Against each area you can see the recommended average lux level or illuminance already defined in the standard. You may refer these standards to figure out the lux requirement in any room or area. Utilization factor is the ratio of total lumen received on the working plane to the total lumen emitted by the light source. The light flux reaching at the working plane is always less than the lumen output of the lamp due to some of the light is absorbed by the various surface textures. To understand the coefficient of utilization, let's understand through an example. In the figure, we have assumed that a light fixture of 8-watt lighting having efficacy of 100 lumen per watt is installed at certain height, hence 800 lumen is the total output of 8-watt light. Just multiply the light fixture wattage with the efficacy, you will get the total lumen output of the luminaire. Lumen output becomes 600 upon falling on the working plane after taking into account the room reflectance, room shape, polar distribution and light output ratio of the fitting. Hence, utilization factor in this example is 0.75. In other words, we can say only 75% of luminous flux reached at the working plan. In the previous example, we have seen 800 lumen flux getting reduced upon reaching on the working plane. Why this so happened? That's really a curious question. Let's check this out. Determining the coefficient of utilization is most important in lighting design. The factors which influences the coefficient of utilization are reflectance of room surface, geometric proportion of room, luminaire distribution, luminaire properties such as light output ratio, efficiency, photometric properties, etc. One by one we will explain these factors and its significance in the lighting design. Wall surface finishes can play a significant role in maximizing the efficiency of a lighting system because lighter finishes can produce relatively higher light levels and perceptions of brightness. Let's see the figure to understand the reflectance. Suppose there is a wall having moderate color finishing, means not much dark, not much bright. When a light strike on the wall, some of the light get absorbed by the wall color and some of the light reflected back. If we assume that 40% light absorbed by the wall, then 60% is light left what we are getting on our working plane. Hence, light reflectance factor wall is 60%. This is called reflectance from the surface. Higher the reflectance of light, more will be the brightness of the room. Reflectance factor of wall varies with the wall finishing. The values of the reflection factor of the ceiling and of the wall are as given in the table. White and very light colors walls usually have 70% reflectance factor, 70% means 0.7. And that of light colors wall usually have 50% reflectance factor. 50% means 0.5. 30% reflectance factor is for middle tints wall color. 30% means 0.3. And 10% reflectance factor for dark colors. 10% means 0.1. Above reflectance values have been taken for reference purpose from the National Building Code 2016. Reflectance factors and room index are required to determine the coefficient of utilization factor. We will see later how both will help in determining the utilization factor. You can see here the formula of calculating the room index. Room index is a number that describes the ratios of the room's length, width and height of luminaire. Coefficient of utilization table can be taken from the manufacturer for a particular luminaries. Let's see how a room index and reflectance can help us in determining the utilization factor of a light fixture. Here you can see a room having width of 5 meter and length of 5 meter. In this room, you can see a luminaire is installed at a height of 2.8 meter. Let's use the room index formula. Put the value in their appropriate places. We got the room index of 0.89. Room index can be rounded off to the near value, hence 0.89 is rounded off to 1. Now let's see the reflectance factor. Consider the same room and assume that we have moderate color finishing on the wall. Based on that, we can assume that the reflectance factor for ceiling is 50%, for wall is 50% and for floor is 20%. These values can be considered as a standard practice when there is no specific demand by your customer, designer as well as by manufacturer. This is the reference table to determine the utilization factor. To make you understand, the reference table has shown here. You may refer the below table for your work but need to confirm the output from the manufacturer. Let's focus on the table. Our calculated room index is 1. And our reflectance factor are Ceiling reflectance 50% means 0.5. Wall reflectance 50% means 0.5. Floor reflectance 20% means 0.2. Now let's see the corresponding value in the table against the room index and reflectance factor. You can easily figure out the utilization factor value, which is 0.72. Hence we can say 72% of lumen output of light is being utilized in our design. So far we have learnt the influence on utilization factors by the reflectance of room surface and geometry proportion of room. Now we will be going to learn how luminaire distribution and its properties will influence the utilization factor. Luminaire properties such as polar curve or photometry properties of a light fixtures affects the utilization factor. To understand the polar curve of light fixture, we have shown here a polar curve of 20 watt light, having efficacy of 100 lumen per watt. Hence, fixture will generate the lumen flux of 2000 lumen. Engineers use polar curves to plot the level of the intensity at any given point. In other words, a polar curve tells an engineer how LEDs spread light across a room or surface. This distribution may be narrow, wide, indirect or direct. Now let's understand the polar curve. The center point is point where fixture is mounted. If we draw a virtual line at 90 degree, one can see that luminous intensity of tube light is below 90 degree and falling direct on the work plane. Hence the distribution is direct. No luminous intensity distribution above 90 degree region. Let's see how can we categorize the distribution as direct, indirect, semi-direct, diffuse, etc. The diagram illustrates the distribution of luminous intensity in candela of the luminaire. The photometry curves provides a visual guide to the type of light distribution produced by the luminaire. Let's us see one by one. Direct distribution. More than 90% light from the source falls directly on the object or the surface to be illuminated. Light fixture having direct distribution will have more utilization factor as most of light distribution is falling on the desired work plane. Semi-indirect. In such distribution, 60% to 90% light falls upwards by diffuse reflection and 10 to 40% downwards. Such distribution will have low utilization factor. Diffusing distribution. Such light distribution have almost equal distribution downwards and upwards. That is 60 to 40% all around the light source. It will have poor utilization factor. Semi-direct distribution. 60 to 90% light fall downwards directly on the working plane, but a considerable amount around 10 to 40% reaches the ceilings and walls also. Such a system is best suited to rooms with high ceilings where a high level of uniformly distributed illumination is desirable. Such distribution will have low utilization factor as 60 to 90% light distribution falling downwards and 10 to 40% upwards. Indirect lighting. In this form of lighting, light does not reach the surface directly from the source but indirectly by diffuse reflection. In this distribution, 90 to 100% light is thrown upwards on the ceiling from which it is distributed all over the room by diffuse reflection. So we can conclude here. Light with direct distribution will have high utilization factor than the light having diffuse distribution. So we have learned that utilization factor depend on the three factors. First, reflectance factor. Bright wall have high utilization factor due to good reflectance properties than the wall with dark colors. Second, geometric proportion of room. High room index with multiple lights will have high utilization factor than compared to the smaller room with low room index. Third, luminaire properties and distribution. If the luminaire having direct distribution, then it will have higher utilization factor as most of the luminous intensity will be fall on the desired work plane. If Luminaire having diffuse distribution, it will have poor utilization factor as most of the luminous intensity is not falling on the desired work plane. Manufacturers publish tables of utilization factors, and these various values are dependent upon the luminaire distribution and the room reflectance. In addition to that, it's also depend upon the ratio of wall surface area to ceiling and floor surface area. Maintenance factor, MF, is the term used to take account of the reduction in illuminance over the maintenance period due to room surface maintenance factor, luminaire maintenance factor, Lamp-Lumen maintenance factor, lamp survival factor. Maintenance factor is product of all. It has to be kept in mind that light is absorbed by smoke and dust along with moisture. This amount of absorption must be considered in the design even in an apparently clean atmosphere. Now let's understand room surface reflectance factor. More dirt on the wall changes the wall reflectance properties. Interreflection is closely related to the distribution of light from the luminaire and the room index. More interreflection in case of indirect distribution results in lux level reduction. Interreflection has little effect on the illuminance produced by the downward distribution or direct distribution. Hence, to maintain the desired lux of a room, keep the room surface clean as possible as you can. Dirt deposited on the luminaire or in the luminaire will cause a reduction in light output from the luminaire, which ultimately causes the reduction in lux level of a room. The rate at which dirt is deposited mainly depends on two factors. First, type of luminaire construction. Dirt deposition in the luminaire will be less for IP rating fixture of 54, 65 and 67 as compared to the fixture of IP rating of 20. Second factor is type of environment in which luminaire installed. Whether very clean, very polluted, less polluted, etc. Extent to which dirt is present in the atmosphere, which is in turn related to the nature of the dirt generated in the specific environment. Now let us understand the lamp-lumen maintenance factor. The lumen output from all lamp types decreases with time of operation. The rate of fall-off varies for different lamp types and it is essential to consult the manufacturer's data. From such data, it is possible to obtain the lamp-lumen maintenance factor for a specific number of hours of operation. The lamp-lumen maintenance factor is therefore the proportion of the initial light output that is produced after a specified time and, where the rate of fall-off is regular, may be quoted as a percentage reduction per 1000 hours of operation. Lamp survival factor. It is essential to consult manufacturer's data. These will give the percentage of lamp failures for a specific number of hours operation. Lamp survival factor is typically assumed to be 1 for LED. Now we will see how maintenance factor is important in the lighting design through an example. So far we have learned maintenance factor depends on the room surface maintenance factor, which can be taken from Society of Light and Lighting Code, clause number 18. Then luminaire maintenance factor, which depend upon the IP rating of the light fixture, luminaire type and type of environment, whether clean, very clean, normal or dirty. Next is lamp-lumen maintenance factor. This factor can be taken from the manufacturer LM80 test report. LM80 test report tells you about the depreciation of luminaire over a period of time under certain conditions. Light survival factor for LED is usually to be considered 1. Now we have fully understand what is maintenance factor. Now let's see an example to understand that why it is important in the lighting design. Let's suppose we have to maintain a 200 lux level in a normal large space room. As per the manufacturer data, application life of 200 watt luminaire is 9 years or 50,000 hours if the light used 15 hours per day. means 5,475 hours per annum. And it is also given that Luminaire to be cleaned at every 3 years. Specified operating hours also specified. Now we have two Luminaire, Luminaire A and Luminaire B. Both Luminaire having efficacy of 130 lumen per watt. Hence both Luminaire having 26,000 lumen lamp output. Luminaire having lamp lumen factor 0.7 and Luminaire B having 0.9. Others factors such as Luminaire, room surface and light survival factor are same. Hence, maintenance factor for Luminaire A is 0.54. And that of Luminaire B is 0.7. Let's see the comparison of both Luminaire when installed in same size of room. You can see the result here. Performance of both Luminaire during the initial years of installation. Lumen output is same, due to which lux level of 300 is easily achievable, which is more than desired lux level, that is 200 lux. Performance of both Luminaire depreciated over the time, so at application life, that is, after 9 years or 50,000 hours, lumen output of Luminaire A is reduced to 14,040, which is 46%, due to which lux level of room reduced to 162 lux. On the other hand, due to good maintenance factor, there is only 30% reduction in the lumen output of Luminaire B, due to which lux level reduced to 210, but still within the limit of desired lux level of room. So good maintenance factor of light indicates the less depreciation of light over period of time. What should be the maintenance factor to be considered in the absence of data? The maintenance factor shall be agreed between the designer and customer at the outset. This shall include the planned maintenance program on which the maintenance factor is based. If no maintenance factor is agreed, a value of 0.8 shall be used. Let's see how to calculate a luminaire in a room. Let us assume we have an office room with 30 meter length and 15 meter breadth, and height of room is 4 meters. Generally, as per standard practice, lux level required in the office is 250 lux. Now let's see how many luminaire we need to require to illuminate the office space with 40 watt luminaire having efficacy of 100 watt per lumen. Hence total lumen output is 4000. This luminaire will be mounted at a height of 3 meter. For the given reflectance factors and calculated room index, we can figure out the utilization factor from the below table. Hence utilization factor is 0.69. Let's assume maintenance factor is 0.8. Now using the formula, put all values in appropriate places. So to illuminate the office room with 250 lux level, number of luminaire required is 51. Uniformity play an important role in lighting design. Uniformity is the ratio of minimum lux level to average lux level. The ratio defines the uniform lux level distribution in a particular room. Generally, for indoor lighting it should be 0.7 and that of outdoor lighting it should be 0.4. We can consider these values in our design unless not specified by the customer. Suppose we have room with mentioned dimension. Has mounted the tube light of 20 watt with the efficacy of 100 lumen/watt. You can see the photometry of luminaire. Distribution is direct. We will not go in details how number of luminaire has been calculated, as it is already explained in earlier slides. We will see the importance of uniformity. Now in the figure, one can see average lux at work plane is 244, whereas minimum is 90. Its min lux level in a room is maintained from minimum to average lux. That is 90 lux to 244 lux. Hence, uniformity would be 0.37 at work plane level. This represents that in a room lux distribution is only 37%. But for a good lighting design it should be more than or equal to 70%. Now in the figure, you can see One room has been illuminated with the light and achieved a uniformity of 0.37. You can see the multiple dark patches which make the room having more darkness rather than the brightness. On the other hand, a room with improved uniformity of 0.7 have more brightness and less dark patches. So it is very important for a good design to have uniformity equal to or more than 0.7 to have uniform brightness over the room area. Deluxe online software is a very professional software that help in design, calculate and visualize light for single rooms, whole buildings, streets, outdoor areas and day lighting. It is available free of charge. Link for downloading the software is given in the video description. Friends, we have completed the indoor lighting design. Now to complete your learning, don't forget to watch the part 3, outdoor lighting design and terminology.
Subscribe now and press the bell icon. Never miss an update.